Hi, my name's Daniel, and this is my Java simulation called Music Party. Essentially, it is a music simulation or party simulation in which you can use your mouse to click on objects within the scene, drag objects around, and use keystrokes on your keyboard, specifically DAN, to make robots within the scene dance. For technical requirement number two, the environment should incorporate at least two different types of complex shapes drawn using Perlin noise. Within my program, I have a noise package, and within noise package, I have a few different classes. My two different noises are my music noise and my static noise. The offline state, where there will be a multitude of lines drawn across the screen, and it represents static, like a retro TV that is turned off. And how I did so is by applying Perlin noise to a rotation, and this rotation is applied onto a line. And these lines are all RGB. As for my music noise, I have a multitude of rectangles, and then these rectangles are also rotated using Perlin noise. So I have a seed value that I pass into my Perlin noise method, and this noise factor is applied onto a random of 540 radians to create a rotation. Moving on, fractals that are created using recursion. So I have two different fractals that are created using recursion. They're in my class called Fractal Lights. The first one is within Draw Fractal. The recursive call is being done upon a float value called d. Given the condition that d is greater than 8, it'll be calling recursively and called 4 times. These calls are basically drawing ellipses, as shown here on line 41, g2.draw new ellipses. Each ellipse is unique in the sense that they are being positioned and created on different sizes through diameter, which is d, divisible upon like 2, for example. These are the ellipses from the fractal noise. Moving on. My second fractal are essentially triangles. They're triangles drawn through a recursive call based off of x. If this condition x is greater than 8, which is passed in through a float, and these are factors that are being used to position the size of the actual triangle. So if it's greater than 8, I'll be further reducing it. So it won't be calling endlessly. There'll be a limited amount of calls, but there'll be quite a few as I'm just decreasing it by multiplying it by 0.99. And each one I'm rotating by 5 degrees. Because these triangles are very thin, I didn't want to rotate them too much, and I wanted to keep them relatively aligned to each other. And I'll just show you where they are within my program. So these are the fractal lights that are being drawn through essentially they're triangles drawn with my path. So all the images within my program, for example, the black robot, the blue robot, the MIDI pad, and the studio, all of it's done in Maya. They were modeled in Maya, exported from there as JPEGs, pretty much as a scene like this, except I would just put them into Photoshop and crop them out individually. Each pose is cropped out individually, for example, from this pose to this pose. And they are cropped out as PNGs and then used as assets. So the decorator pattern within my simulation is all within the package called decorator. I have two different decorator patterns, one called mustache decorator and another class called swag decorator. mustache decorator essentially draws a mustache on top of a line image, and my swag decorator essentially draws a pair of glasses on top of my line image. And my line image is within my basic character. My base character here I call lionhead.png. This lionhead was created in Java in assignment 1 to 3, and I took that lion and screenshotted it. Then I put it into Photoshop and I pen tooled it out. So I exported that lion head as a PNG. Furthermore, I have 5 different sound effects within my simulation. One background sound, which is background music, and I have 4 different sounds that play in certain instances. For example, if I were to click the MIDI pad or pose sound for which whenever the robots go into a dance pose or changes pose to play music, it'll play a pose sound. Whenever the robot hits the podium, it'll play a click sound. Whenever the robot changes pose, it'll click a pose sound. And then the sounds for these are bubble pops when I pop the lights. In terms of structural requirements, for number 4, major objects must be created using factory pattern. I have 3 different factories, and they're in separate different packages. So for the first factory, I have a noise factory, which is within my noise package. My noise factory basically will return whatever noise I need or whatever types of statics I need. They're all type noise, so I have another class called noise here. They're all type noise, so I have an interface called noise here, which will render the types of noise I need. And specifically, the noise within my scene is here to represent it's an offline state because the application is kind of a retro feel. This kind of emulates like an offline television or a very static television. The second noise is here. These are the rectangles that are being using Perlin noise to rotate, and these are 2 different types of noises I use my noise factory to return. The second factory, I have an onboarding factory. So my onboarding factory will basically take in all the different steps, which are strings here, and position them uniquely based off of where the interaction needs to be. It'll give some room and allow me to instantiate and encapsulate my code from any clients needing to use it. They don't necessarily need to know how I pass in where my onboarding is taking place within the scene. So lastly, I have a studio factory. All the objects in my scene, the major ones are buttons, and to encapsulate and create them, I use a studio factory to create them. So based off of what is passed in, let's say if it's a blue robot, it'll return a blue robot for me at whatever position I needed it to be. They are created in a fixed sense here because I designed the simulation to have them in certain positions and certain areas. Therefore, it makes sense for me to pass it in here and not let the client affect any of this. Moving on to the next structural requirement, code must be refactored and to prevent redundancy between superclasses and subclasses. So within my studio, they're all buttons. So I have an abstract class called base button, and my base button is being used to pull up all the similar fields and methods they all have. So each button will have a clicked and draw. Also, they have a position and scale and image associated to them. So I pulled all those up and put them in base button. Furthermore, I have a base noise. So all my noise have similar, if they have similar fields like X seed, Y seed, X start to affect Perlin noise, which I'll be passing in, which these are the variables that are being randomized. I pulled these up so it prevents the redundancy there. Furthermore, within my lights package, here I have different types of disco lights. So first of all, my simulation lights here. Furthermore, in my lights package, I have disco lights, which are a basis for my interactive disco lights. But first, I have my simulation lights as an abstract class. This class pulls up a lot of common fields, such as the position and velocity, because my disco lights move randomly and they also respawn after a certain time. So all those fields that share similarly, such as the respawn, which is the lifetime, I pulled up to place in here. Similarly with the move method as well. There's a difference between my different types of disco lights. So my actual interactive disco lights, these ones are the ones I can interact with. They're the neon green ones with the yellow border that if I click, they will disappear. These ones, I needed to implement a clicked method and a get position method as well here. The get position is so I could use the positioning and place different things on top of it, which I'll get to later. But my super disco lights extend from my disco light, and these are just the standard disco lights that I will be calling. Within my decorator package, I have an interface called char interface. This interface has a method called void decorate, which is being used commonly across everything. So I pulled that up. Additionally, all my different decorators, such as my mustache decorator and my swag decorator, they both had commonalities into how they were decorating. So I pulled up everything into a class called char decorator, and they all had different fields that were being used, such as image, the X position, Y position, and scale. These were pulled up. Additionally, the decorate method I also pulled up. And they all, for example, the swag decorator extends from my char decorator, similarly here from my mustache decorator. Moving on to the last structural requirement, the sixth one, use try and catch to handle runtime errors or potential runtime errors. Within my util package, I have an image loader and a minim helper. So my image loader will help me handle try and catches for image files, and my minim helper helps me handle try and catch for my audio files. So here's a quick run through of my music party simulation. You start by clicking start, and you are in this offline state. It's a retro feel, so I went with some Perlin noise and added a filter on top of my background just to show that it's off. You start by clicking on the mini pad, and then everything will turn on. Music will start playing, and it'll keep looping. These simulation lights are created, and they all have a wall detect and a lifetime, and they just regenerate after a couple seconds. Your first step is to click on the blue robot and drag it to the podium. So you would just drag it to the podium and it will stand there. Next step is to click on the black robot to assist you by playing the MIDI pad. These lights are generated with Perlin noise through a rotation. Following, you're asked to kill all the bad vibes within the room by clicking on the green lights. So these neon green lights with a yellow target box. Once you click them, they also make a pop noise. You have 4 of them. So after all they're done, you'll be asked to make your blue robot dance. So you click D. So that's its first dance state. You see how the environment's slowly deteriorating. It's to represent environmental changes. Click A. Further changes in the environment. The MIDI pad is being played, and then you're prompted to play, press N to put the dance into another position. But before we go, here are some fractals that are created by recursively calling some ellipses. And then here I have a blip animation of the black robot playing the MIDI pad. Concurrently, the robot and the MIDI pad changed through 2 different states to represent it as being played and it's blipping. Now we want to use the decorator patterns within our simulation. So first we click the swag button and it'll spawn a lion with some sunglasses onto the green lights. But you can also spawn a basic character, which is just the lion head that I created in Java for assignment 1. All of them are drawn with graphics 2D with quadratic and cubic arcs. But before we can move into the next state, we have to clear these 2 stages by clicking the swag button and mustache button. So we want to clear it first, and then click the mustache button. So now the program knows we've clicked both buttons, and we can click the USB to finish the simulation. And then now we are in state -2, which is the restart screen. And by clicking restart, we can go back to the start screen. In terms of eco requirements, the first one I was aiming for is the day to night transition. I have starting off my scene with a night time, and this is done through a filter placed on top of my whole scene, and then when the mini pad is clicked, the filter will be removed and it'll turn into daytime, and following the actual lights and the disco lights turn on, and that will be the first MIDI or eco points that I would like to acclaim. The second eco are the self-created images. So all the models within my simulation are self-created in Maya. As I explained earlier, they're just created in Maya, modeled in Maya, and exported to Photoshop, which they are cropped out to create separate objects. The third eco, which I would like to claim, are from interactive lights. So these lights all have a wall detect and a spawn time, as opposed also the neon green ones that have this yellow target border. These ones are clickable and they also have a wall detect. When they're clicked, they're removed, and one of the objectives within the simulation is to kill all the bad vibes, so you please click on the green lights. So after all the green lights are clicked, you can move into the next state. Based off the complexity of the implementation and from a reflection of the teachings from assignment 1 to 3, I would like to claim that this is also an eco feature. Moving on to gradual environmental changes. As the simulation progresses further, the environment slowly crumbles or like deteriorates, along with some details from the actual podium and the MIDI pad. They also do deteriorate throughout time due to the fact that the studio is placed indoors and cannot have like seasonal changes. I followed along with environmental changes that were gradually occurring throughout the environment. So looking here in the next one, the walls here have deteriorated further to symbolize that the party is increasingly getting stronger. Furthermore, also the MIDI pad is changing state and the floors are deteriorating further. And that is the second 2 points for that I would like to claim for gradual environmental changes to supplement for seasonal changes. Next up is 4 plus states based off of FSM. My MIDI pad and my podium, in addition to my studio, all have more than 4 different states. My MIDI pad has 6 different play states to showcase, for example, this is one state which is crumbled and has no lights turned on. This is to show it's crumbled and it has being played and it's along the vertical direction of the keys. Additionally, the environment also have state changes. The podium or the blue robot is changing different dance positions, and the actual podium, if you can see here, is slowly crumbling as well. As opposed to the base here is what it initially looked like. For evidence, here is a reference of what it initially looked like. The next eco that I would like to go for is the blip animation. The robot is blipping through 2 different states, as so is the MIDI pad. The MIDI pad is turning on and off, and the robot is going from play to not playing. And here is the blip animation. So the last eco that I would like to go for is for the decorator patterns. I have 4 J buttons that create decorator patterns. One is to create the lion head, one is to create the glasses, another one is to create a mustache. And the mustache is shown here. So these decorator patterns are placed on top of my interactive disco lights. In this state, the interactive disco lights are actually not targetable, so you cannot click them to remove them. I felt like it would be interesting to place the decorator patterns onto the lights, as they have wall detect and they'll stay within the scene, and it adds another interesting dimension to my images as they'll be moving across the scene as opposed to being in a static position. And I would like to claim 2 eco points for this. I'm aware that I've currently counted up to 7 different eco features, as shown here. One for interactive lights, self-created images, day and night, gradual environment changes, 4+ states, blip animation, and the decorator patterns. Hopefully that will equate to 14, but I understand that we can only claim a maximum of 12. So hopefully this rounds down to 12 points in the end. Moving forward within the simulation, after you've clicked on the combination of the buttons by trying the different decorator patterns to help support the black robot by showing you're modifying the lights, a USB will appear on the screen. This will be the soundtrack that the black robot has created. So after clicking the USB, you go into the last state, which is state FSM equals -2, which is the restart screen. And then you can restart the simulation. Here's a page showing the assets that were not self-created. A link is provided to Epidemic Sound for the music. Sound effects are provided, and the narrator PNG is from a Maple Wiki site. Aside from that, everything else was self-created.